Assalamu alaikum dear students. Welcome back to my channel Chemistry Master. Today in this video I will solve this question from the 9701 chemistry of October number 14 and variant 13. Question number 30 states methyl butanoate C5H10O2 is an ester used in the food industry to give products the flavor of apples, and we have this displayed formula of the methyl butanoate. Including methyl butanoate, how many structural isomers are there of C5H10O2 that are esters? So basically in this question we have to draw the structures, the structures of the isomers, and the conditions applied here are that the structure must have esters in it, and we already know the molecular formula. These must be present in those isomers. So we have multiple structures which we can get from this molecular formula. The one of those isomers is already drawn here. This one is already drawn, but now we have to make our own isomers out of it. So let's start here. We know that I can make the this structure as the easiest one. Like suppose I can represent the methyl group as simply C. This is called as the skeletal formula or the structure formula. For an simplicity, I can write it as CH3, and then I have O, C carbonyl, and now I can write as CH2, CH2, and then comes CH3. Even for more simplicity, I can write it as C, O, C carbonyl, C, C, and then C. This will make an even more simple because we have to draw out more isomers from here. I can label it as isomer number 1 because this is according to the displayed formula already in our question. How else can we make isomers from here? I can do this simply by changing the position of this ester group. If I change its position, then I can get another isomer. Let's suppose carbon, carbon, and then oxygen, and then carbon with carbonyl group, and then we have carbon and carbon. This is the isomer 2. You can add the hydrogens to complete the structure. Now we have drawn the structures according to the positions of the carbonyl. If I try to make another isomer of this type, carbon, 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 oxygen, carbonyl, and this carbon, these two will you can see that these two are not same because this methyl is bonded with the carbon, whereas this carbon is bonded with the carbonyl. So there is a difference. These two are not same, so we get another isomer here. Now I can make some modifications in the first isomer, but not in terms of the position of the ester. Instead, I will make some changes in the chain of these carbon atoms. How can I make modification? I can simply convert this straight chain into the branch chain. So this will become the fourth isomer. So I'm writing the first isomer again, but with some modification. This is carbon, oxygen, carbon with carbonyl group, and this carbon will be bonded with carbon in the form of the branch. So this is giving me the a modified version of the first isomer. So this will become the fourth isomer. Now another addition or another change I can make from here is that instead of you can see here that this branch or this group is bonded with the carbonyl group. How about if I bond this group with the oxygen? Then I will get another isomer. So here, this is the carbon bonded with another carbon like the branching, and it is bonded with the oxygen and another carbon having the carbonyl group and then methyl. So this is the fifth isomer. So I have got 5 isomers now. Now by considering and uh, by using the formula and using the condition of ester, I can make another isomer. That isomer, let's suppose I will show those isomers in the another form. We know that ester should have this type of the functional group where R and R prime are different. If we represent R prime as hydrogen, then this will become a carboxylic group. This is not our this is not according to our condition. This will violate because this is not an ester. But if I represent R instead, if I represent R with the hydrogen, so I can make this one as hydrogen. This will be considered as an ester. It is still an ester. So using this new method, I can now draw more isomers. The isomer now starting from the same isomer number 1, I can make new isomers. I will write as HCO carbonyl group, and then I have oxygen, and then carbon, 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 and carbon. I have this as another isomer. This will become 6th isomer. Now I have to make some changes. I will not change this position because this will remain as such, but I will make changes in this chain. So 7th isomer will be like hydrogen, carbon, carbonyl group, oxygen, and then this carbon and then carbon. This will be bonded with 2 further methyl groups. So this is the 7th isomer. The 8th isomer, it shall be like hydrogen. Let me change. 8th one will be hydrogen bonded with carbon and then carbonyl, oxygen, and then this one carbon will be bonded with 3 more methyl groups. 1, 2, 3, 4, 5. So this is the 8th isomer. Then the last isomer I can make is 9th one. It shall be like hydrogen and carbonyl over here, oxygen, and then this carbon is bonded with the ethyl group over here, and then there is a methyl group over here. This is methyl and this is ethyl. You can see from these isomers that none of these structures resemble with each other. All the isomers are different. I can show here. This is the straight chain. This branching like this, and then we have branching like this, and then we have branching like this. So none of these isomers resemble each other, and that's how we get 9 different isomers, including the one which is already present in our option. So that's how the correct option becomes the C. The correct option is C. Hopefully this question has helped you in solving this question. If you have any other question for me to solve, you can just ask me in the comment section or contact me on my given WhatsApp number, my email address, and do join my WhatsApp group and join my Google Classroom for more educational videos, and keep I will keep making more videos on the questions. So that's for today. We'll meet again in the next video. Till then, take care and Allah Hafiz everyone.